We're building things in tougher places than ever before. We're talking about critical infrastructure that supports all of us, from deep mines to our biggest cities. And in these places, failure isn't just some small problem. It can be absolutely catastrophic. Today, we're going to look at an engineered system that's designed to thrive in exactly these kinds of harsh conditions. Just look at these two worlds. On one side, you have these pristine waterworks facilities. They are, quite literally, the lifelines of our cities. Any failure there has huge public health consequences. And then on the other side, you've got the gritty, rugged world of mining, where abrasive slurries can literally eat right through standard pipes. Both of these environments demand infrastructure that can handle immense, but totally different kinds of stress. So that's the big question, right? This is the central challenge for engineers today. It's not just about building something strong anymore. It's about building something smart, something resilient, and something efficient enough to handle pretty much anything you can throw at. So, how do you actually do that? How do you build a pipe that can handle corrosive water just as well as it handles abrasive mining slurry? Well, let's dive in and break down an engineered pipe system that was designed for exactly these extremes. Okay, so the foundation of this whole thing is something called ductile iron. Now, this stuff is known for its incredible strength and durability for sure, but what makes it really special is its flexibility, its ductility. That means it can actually bend and deform under stress instead of just shattering. That makes it the perfect base for a high-performance system. And this is where it gets really cool. The system brings together three key things. First, you have that super strong ductile iron core. Then it's covered in a specialized epoxy coating that fights off both corrosion and wear. And finally, the game changer, a joint system that lets you assemble it incredibly fast with no welding at all. It's like a triple threat of engineering. All right, so how does this tech actually perform out in the real world? Let's start with our first critical application, making sure our communities have a safe and reliable supply of water. Seriously, think about it for a second. When a city invests in a new water main, it's not a short-term patch. They're making a decision that's going to affect people for generations. So what should the benchmark be for that kind of investment? Well, thanks to its advanced corrosion protection, RASHMI-LOCK is engineered to last for over a century. This is not just a pipe, it's a long-term public asset designed to serve communities for generations to come. Okay, so lasting a long time is one thing, but water systems operate under incredible forces. Just managing that constant pressure, day in and day out, is a massive engineering challenge. So how does this system handle all that pressure? Well, it's designed for some unmatched performance. It can withstand up to 100 bar. Now, to put that in perspective for you, that's about 100 times the atmospheric pressure at sea level. That provides a huge margin of safety for any city water grid. So here's the crucial point. It's a complete solution. Those push-in joints, they mean faster, cheaper installation without needing these massive concrete blocks. It's also certified safe for drinking water, which is obviously critical. And remember that high ductility we talked about? Well, it means the pipe can literally flex with ground movement, making it super resilient in seismic zones. It's actually proven to be earthquake-proof. All right, let's switch gears completely. We're going from clean water to an equally hostile but totally different environment, the grit and grind of modern mining. In the world of mining, the biggest challenge is moving slurry, which is basically a mix of rock, minerals, and water. This stuff acts like liquid sandpaper, just constantly grinding away at the inside of a pipe. And this system is perfectly suited for those challenges. That epoxy W75 lining provides best-in-class resistance to that constant abrasion. The fast, no-weld joints are a huge win when you're working deep underground. And that same 100 bar pressure capability is absolutely critical for moving all that material efficiently. Okay, so we've seen how it performs in two very different worlds. Let's kind of zoom out now and put the core benefits side by side to really get the bigger picture. This really shows you just how versatile this system is. For waterworks, the big deal is that century-long service life and seismic resilience. For mining, it's all about beating abrasion and allowing for fast deployment. It's the same core technology, but it's tailored to solve very different problems. The key takeaway here really boils down to reliability, no matter what the context is. Whether you're trying to guarantee public health with safe drinking water, or you're driving economic progress by extracting resources, you absolutely need a system that will not fail when it matters most. And look, these aren't just empty claims. This system is backed by rigorous third-party testing. It's got the BS 6920 certification from NSF Lab UK, which is a globally recognized standard. It guarantees that it's safe for contact with drinking water. It's that final stamp of quality and trust.
So, as we wrap this up, it really leaves us with one final thought. We are faced with some immense challenges today: aging infrastructure, climate change, you name it. Investing in technology that's engineered not just to last, but to actually thrive in these extreme conditions, well, that might be one of the smartest decisions we can make.